Okay, so my name is Pascal, and today I want to talk about how to not break your GraphQL clients. I work for a company called Chili Cream, as you can tell by my outfit, and we are very active in the open source space, and we work on a server called Hot Chocolate, which is written in .NET. We're also known for GraphQL Fusion, which is one of the foundations which now goes into the composite schema specification, and we are very active in this space as well. We also do tooling for it, namely Banana Cake Pop, which you can see here, where you can manage your documents, share them with your team, and also do monitoring. We have an open telemetry API where you can send us your open telemetry data, and we can visualize that, and then you get really deep insights into what's happening on the server. So now that you know me, let's talk about how to not break your GraphQL clients. The GraphQL schema is the most important artifact of your GraphQL API. It's the contract between your client and your server. A modern API usually has more than one client. Maybe to your web app, you also have a watch app or a mobile app. And maybe even a coffee machine. We actually do have a customer which runs hot chocolate on a coffee machine where you can get coffee out of the hot chocolate out of the coffee machine. So it's the nature of such a schema to evolve and change over time as you add functionality and you add features. So it's also naturally that this contract changes over time. And it would be very bad if this contract breaks. But it's very easy to break this contract, even when you have good intentions and you want to fix a typo. It could be that one of your clients actually uses this field, and then you may accidentally break a client. And I'm going to quickly show you how easy it is to break a client based on this demo application. Simple to-do app, and you see you have to-dos, and you have different offer of to-dos. And what we have to do, we just got a new requirement from the product manager that we have to add in the age of AI to-dos. So what do? We go into code, and we add AI to-dos. But AI to-dos have something special. They don't have an offer because they're generated by AI. So what we have to do is we have to make the offer they're created by optional. And then let me restart the server. And when the server runs, we should now have AI to-dos in our to-do app. So let's go back, refresh the page, and boom, our application is broken. And when we go into the code and we look at the front-end code of this, we see that the front-end actually expects there to be an offer. But because the offer now is nullable, there is no offer anymore, and the application explodes. And this is because the schema has changed. We have made a nullable field, a non-nullable field nullable, and therefore the contract broke between our API. There's an easy way how you can prevent such issues. And we took, as I said, we are a .NET company. We build tools in .NET. But you can, the idea of this we actually have from JavaScript. And what you can do is you can do schema snapshot testing. So when you have a look at this, we have a snapshot test where we create a in-memory schema, and then we print the schema and we snapshot it to the disk. And the next time the test runs, we do this again. And if the schema is different, then we assert. So let's quickly run the test and see if the test would have prevented that. Nope. Second. Let's make this a bit bigger. This we don't need anymore. So, and the snapshot test now fails. And it shows that we have a change in the schema, and that the schema now, that this field now is no longer non-nullable, and therefore we have a change which could be dangerous. And even if there's better tools than snapshot testing to manage your schema, I will show you this, you should still have one of these snapshot tests. Because when you do pull requests and you have changes in the schema, oops. and you have changes in your schema, then you see in the pull request quite easily what has changed on your GraphQL API, and it's a good point to start a pull request review where you see what actually changed on the API. Okay, so let's have a look at the problems of snapshot testing. The first thing is it doesn't scale. And you don't have to be a huge team. It could be a one-man project. When you have many changes in your pull request, there's also many changes on the API, and it becomes very difficult to track which part are actually dangerous changes and which are non-breaking changes. So even a one-man project can have a huge diff. The second problem is it's very difficult to share this knowledge about a breaking change, about what breaking changes are and what are non-breaking changes through the whole company. So you either have a select few people reviewing all pull requests, or you have to distribute the knowledge. And the last problem is GraphQL changes are really complicated. You may say that the change that we had before was an easy one. You change the nullability, it's null, you call a method on null, it explodes. But what do you think about this? Is this a breaking change or a non-breaking change? Breaking change? Non-breaking change? So you kind of are both right, because there's three categories of changes in GraphQL. There's the non-breaking changes. These are the easiest ones, what we do all the time. We add a field, we add an argument with a default value or with a null value, and we add a new type. And then there's dangerous changes. The things, for example, adding an enum member, like we just did before in the slide before. The problem here is that depending on what technology your client is built in, it could be that it breaks the client. In JavaScript, you usually don't have the problem because you just take what you get from the server. But if you have a Go client, a Java client, a C# client, it could be that the serializer doesn't know how to deal with this new enum member and then explodes because there's no enum representation in the code in the client itself. And the last category are the breaking changes. And these are the obvious ones. You remove a field, you change the type of a field, but there's also more difficult ones when you remove an executable directive, although that's more of an exotic use case. I doubt that many people have custom executable directives. So how can we do better than just snapshots? We can use a scheme registry. A scheme registry is integrated in your CI pipelines. And what you do is you send your schema to the schema registry. The schema registry stores it, then processes the schema, compares it to the older version of the schema, and puts out a change log where you see what has changed, if these are any dangerous changes, breaking changes, and so on. The idea of such a scheme registry is that you put them into your continuous integration pipelines, for example, in your pull request or release pipeline. In the pull request pipeline, you would first validate the schema to see that nothing has broken. And after that, you can build and test your application, because then you can stop early and you don't even have to do the other things. And in the release pipeline, it's slightly different. You would build your application, and then you would upload the schema to the schema registry. And before you do the deployment of your application, you publish it to a certain stage. For example, you publish it to the stage dev. The schema registry stores a history of all schemas that have been uploaded over time. And you add a tag to that, for example, a commit ID or a custom tag like here. And when you push a new version, it's added to the schema history. In applications, you usually have more than one stage. So you not only have a production environment, you also have a stage like development, where you push more often than you push to production. Therefore, you have a different history of changes. You see we have published 0.5 to development, and when we now publish the version 6 to development, you see that we only have one change. But when we do the same thing with production, where we don't deploy as much, then you see that we have multiple changes there. And that means that it could be that you actually can deploy to development, but as soon as you deploy a change to production, even if everything is green, it could be that it still fails because they have a different history. I also have a little demo for this. And when you have these schema snapshots, you have quite a good foundation. 1 second. you have quite a good foundation to upload the schema. I will use Banana Cake Pop. This is our tooling here to demo a schema registry. But there is also Hive from the Guild that can be used as a schema registry. Or there's Apollo with the GraphOS, which is also a schema registry. And I will use our tooling because it's the only one I know how to do it. And yeah, so what we have here is we have created an API. And this API has two stages. We have development and we have production. And what we want to do is we want to upload the schema to the schema registry. So for this, we use another very well-named tool of us called Barista. And what we do is, let me open the script quickly. We first upload a schema. And you see, that will not work. I need to go back. Like this, I believe. Let's use 20. And you see I used the snapshot file, which is already on the disk. And therefore, the snapshot has another use case, not only for pull requests, it can also be used for schema registries. And now what we do is, actually, that was a mistake, because we haven't accepted the snapshot. 1 second. When we run the test, not only does the test fail, it also generates this mismatch folder. There's in JavaScript, I know there's plenty of tools which do something similar. And what we do is we accept this, and we know now that there is a change in our schema, which is quite naturally. Now, what we do is we upload this again. Now a different version. And now the changed schema is uploaded, and now we can publish it. So let's publish the schema 21. And that shouldn't have worked. So let's do this. 1 second. It's now breaking. That's good. There we go. It was still from the last time I did the talk, the wrong schema active. You see that the publishing to the schema registry failed, and it tells us exactly where it failed and why it failed, because this type has changed. And with this, you can have huge schema diffs, and you can still make sure that you don't push something that would break it. Now, what we can do is we can obviously override this in case that we actually want to do a breaking change, like this. Nope. Like this. Still nope. There we go. And when we go into the tooling, you see now that we have a new version published, and we see that there was a breaking change in it. Good. As said, there's other tools that do the same thing. They also have CLIs, so the flow will stay the same, because it basically represents how the real world works, more or less. And there we go. And that's the reason why most of them work the same. So we're safe now, right? We have a schema registry. We know we can't do breaking changes anymore, so we should be good. If we have integrated this, we're fine. We don't have to fear deployments anymore. But that's wrong, because sometimes you actually want to break the schema. Over time, when you add features, you also deprecate features, and you want to remove the schema. So you will inevitably have breaking changes in your schema. And when you now always have to verify them manually, you run into the same issue as before. You have huge schema diffs, and then there's actually not really a win. So what do we do when we want to break a schema? And how do we even know what the requirements are to our schema? And that's because the schema is just half the story, because you also have clients. And each of these clients has different requirements to your server. And each of these clients has its very own version number, and is probably maintained when you have a mobile client and a web client by different teams. So now you have a backend team, which does the server. You have a mobile team, which develops the mobile app. You have a web team, which does the web app. And you somehow have to make sure that all of this, that the schema and the clients are always aligned. And to make matters worse, with mobile apps, you have people like me, which do not update their apps so regularly. And then you have the problem that you have multiple versions that you have to maintain. So even when you have your main branch in Git and you compare this to the schema that you have, so you take the main branch in Git from your mobile app, look at the queries, and compare it to your schema, it could be that there is still some version out there from 6 months ago which uses a different query, and then you basically would break it when you remove a field. Every time when you publish a new schema, you now have to verify that all the published clients of all the applications are still valid with the schema. And this is just for one stage. When you have another stage, you have production, and in production, different versions of the client can be active, and you see that this gets really, really complicated, and it's really hard to deal with. And that's exactly why you should use tooling to do something like this, because then it gets rather easy. Before we go into another demo, you have to ask yourself the question how you can know what fields and what requirements a client has to the schema. And all of the good GraphQL clients, actually most of them nowadays, have the ability to extract the queries which are used in the application. On the left, you see a relay component with a fragment, and on the right, you see the extracted persisted query JSON file, or persisted operation, or trusted documents, or however it's called at the moment. And what this does basically is it takes the query from the application, it hashes it with SHA-256 or MD5 or whatever, and then it creates key value pairs between the hash and the query value. And what do you do with this JSON file? You send it to the schema registry, and now the schema registry knows the schema and it knows the client. And what it can do now is it can verify that in each client push and in each schema push, everything should still work together. So let's see if we can emulate that. For this, I need script 3. There you go. So first off, let's have a look at this persisted query file. It's a rather simple application. We use relay, so we only have one query, you only have one screen. And what we want to do is we want to upload this now to the server. For this, we need to first upload the client. So what we do now is we basically say that we want to upload this operation file, the persisted query file, to this client, and with this tag. And as we have uploaded it, it should appear in Banana Cake Pop as well on the clients. There you go. So we have the web client, and you see the version is now uploaded. And now we will just publish it. There you go. And now the client is published. Now, what we can do is we can now quickly break the schema and see what happens when we, for example, remove created by. And then let's client validate. The validate command doesn't upload anything. It basically just validates. That's wrong. Validate. This one I need. The validate command basically just doesn't upload anything, and it just validates that the schema still works together. And when we do this now, we see that we have removed the to-do field, which is a breaking change. But we also see that we have broken 2 queries, which are deployed in these versions, and it tells us why these queries are broken. And with this, you actually know what fields are used. And if you take this a bit further, you can actually say there's also mode in this in most schema registries. You can tell the schema registry that you want to allow breaking changes in the schema as long as they don't affect my clients. And that's how you should do this. Good. Now, persisted queries, or trusted documents, or whatever they are called now. If you take away one thing from this conference, use persisted queries. Because persisted queries have one big benefit. You have now this hash, and your client knows this hash. And it can make a request to the server with this hash, and you don't have to send the document anymore. The server then calls the schema registry, gets the executable document, and can execute the query. Now, this is more efficient, and this makes sense because it's more efficient. But the actual benefit that you get, it's not about efficiency, it's about security. Because if a malicious attacker now creates a query and sends this to your server, you can just reject it and say, I only want persistent queries to be executed because I know these are queries which are crafted by my people, my employees, and I don't want anyone else to execute queries on my server. So all the issues that were in the past, which were GraphQL ecosystem-wide, were parser issues, lexer issues, and all of these kind of things. So you don't even have to have broken access control or whatever with GraphQL. If there is a well-known bug, it could be that someone sends you a query and your server goes down just because there is some bug in GraphQL.js or something. Good. Now, if we only accept persistent queries. Now, if the attacker then hashes the query and sends the hash, we don't know what to execute because we have no longer a document. There's no way back from hash to document, so we can also just reject that. With client registry, you can now have a different flow than to the schema registry. You can upload your clients, you can publish them, you can deploy your app to the App Store, and then after that, you can unpublish your client. And by this, you make the flow possible, which GraphQL intends to use for versioning. You can deprecate the field, you can phase it out, and then you can remove the field. If I have to summarize this talk in one sentence, it would be a schema and the client registry allow you to break your GraphQL schema without regrets. Thank you for listening. If you have any questions, you can ask them now. Or you can catch me outside in the hallway if you want. If you prefer that. Yes, please.
I have a situation with like dynamic schemas. We generate parts of the schema.
Yes.
How feasible is some of this?
Yeah, so the question was, I'll repeat because of the recording. The question was, what about dynamic schemas? Yeah, they have the similar problem to public APIs, right? When you have a GraphQL schema like GitHub that people write queries against. And they provide a bit of a unique challenge. It really depends on your setup. So when you have dynamic schemas, it could be that maybe you can also generate these persistent queries dynamically, just the hashes, and then make sure that this is still secured. Dynamic schemas have many issues. Or I wouldn't say issues. It's much more difficult to have a dynamic schema than to have a static one, because that also means that you have to have in your server multiple versions of this schema running in parallel, which is a bit memory intensive. But it definitely is a challenge to do something like this with it. Do you also generate the clients, or are the clients just some customers which then write queries to your server? Yeah. So open-ended, pretty much both. Yeah. As soon as you have a public API, this becomes difficult. You could still ask people to upload their queries and stuff, but it's much more difficult to doing it in a closed-down setup. Actually, public GraphQL APIs are very difficult to write. When you provide your API to a customer to make their own queries, this is really difficult to do. Any other questions? Yes, please.
Kind of related to that, could you go into any more detail about your suggested process for the deprecate, phase out, remove period of things? We have a number of in-house teams that work with our graphs. We don't currently have a registry where they push up their changed queries and stuff, but there are oftentimes we need to remove fields or deprecate things, and we can't get them
to stop using them.
right. And so, do you version your API then?
I mean, you shouldn't version your GraphQL API. That hurts a bit. I know from companies which do actually have multiple versions of their GraphQL API, but usually what they do is they start a project, and then after the project is finished, they realize what they should have done. They learn GraphQL in this project, And then they make a version 2 of it and make everything right until they realize they still did everything wrong and have to make a version 3. But anyway, the flow that you should aim for is that you have a GraphQL server, and then you deprecate the field on the server, and you notify your teams about the change in whatever way or form. But you deprecate it first. And there's a deprecation reason that you provide, and you tell them what they should use instead. And then you just have to live with it, because you cannot remove it until everyone has stopped using it. You can use telemetry to know if someone still requests this field, if you don't have persistent query. If you have persistent queries, you suddenly at some point know that there is no usage on this field, right? Because there's no query using it. And then you can remove it safely, and you know that none of your application broke.
So would you encourage moving to, the persistent queries first as a step of?
Oh yeah, definitely. As I said, it's always persistent queries much more difficult if you have a public API. If you have a private API, Benji likes to say, if you use persistent, if you can, use trusted documents, and you really should, right? I know it's not very well known in the ecosystem. There's still a lot of companies which don't use it, but it really helps with so many problems. It's a bit more coordination problems that you have with the teams and so on. But once you have it built into your continuous integration, it just runs, right? You don't have to worry. And we use, when we deploy our services that we use ourselves here, we use our own system to dog food it. And it was, even though I know what a breaking change is and how to deal with it, I think it saved like 2 or 3 deployments of me where I forgot that I actually have some client somewhere which uses it, right? So I would say go for persistent queries, let them push it. Once you're on persistent queries, you can start removing the fields that are not used.
Thank you.
Always. Yes, please. Sorry? Retention. It depends a bit, I guess, on what product you use. Our schema registry doesn't, so you just upload and the latest versions is stored. While with the clients, it becomes a bit, you want to have more versions than just the latest one. But in the schema registry, it doesn't really matter if you still have the versions from years ago, because that doesn't matter anymore. But the retention time basically is until you push a new version on top of it, and then you don't need the old one anymore. But I mean, in our product, they're still there, so you can, oh, that's wrong, they're still there. You can look at them, see the changes that have been made, and such things. Yes. All right. Any more questions? Okay. Yeah, please.
So if a client has multiple queries, how do you publish the client?
Sorry?
So for a client with a lot of queries, do you
Yeah.
combine all the queries?
Yeah. So let's see if I'm still able to do something like this on the fly. Actually, I don't have time. But yeah, the persistent query documents that you can export from the clients. And Apollo has the same thing. It's a slightly different format, but it's not specified yet. It's coming soon. They will also adopt it. Then you see it's a key value pair. So in this file, you can have many persistent queries. And then you have a client which has many queries, and you can publish that. Yeah. Yeah, please.
So how would you know if a particular persistent query is no longer being used? Is that like a linear, like a window saying if there's no traffic for some amount of time, it's considered unused?
Yeah. So the best way of doing it is when you do it not based on tracing, right? Because when we go back and have a look at this slide, not this one, this one. So you can use tracing to know if a field is used. And if the field is no longer used, you basically just remove the field. The problem with this is a bit that it could be that there's one view in your application which is open very rarely or just in certain conditions. And this part of your application still uses a query which you do not know. So you cannot rely necessarily on the 2 months of tracing data that you have. But when you look at this from an organizational point of view, you usually know which versions you have to maintain. In the web, it's the latest one that's deployed, because as soon as you deploy a new one, the JavaScript files are gone, and then you have a new version. In the mobile apps, you have similar things, because you start to deprecate the old versions in the App Store and start removing them, right? They go out of support, and as soon as they go out of support, you have solved it on an organizational level. And what you can then do is you can do this. You can say that, nope, that you want to, where is the client, unpublish. And then you unpublish the version that you do no longer use. And then the persisted query is also gone. So you know that the persisted query is no longer used. I would say use tracing if you have nothing else. If you can manage it on an organizational level, then use this. All right. Any more questions? Good. I'm anyway out of time. You can, if you have any more questions, you can catch me outside if you want. And otherwise, you can always send me an email at pascal@chilicream.com, or you find me also on the Bird app under Pascal_Senn. Thanks for listening.